The goal for today is simplifying numeric and algebraic expression using the laws of exponents. So what we are working on is actually we are still working on the exponents, but we are not working on exponential functions. So we are either multiplying, dividing, or multiplying. That's what we are doing with the exponents. Just to review, what are exponents? Exponents are those small numbers above the number or the letter. In this case, you are going to see it actually above the letters. So small numbers, exponents are small numbers above letters. Example would be x cube. So this is your exponent. And make sure when you're writing the exponent, it needs to go above the letter. Don't put it right next to it, otherwise it doesn't look like exponent. And it goes on to the right side, not the left. Coefficients. You probably remember this word from the past. Coefficients are the big numbers that are right next to the letters. And they're in front of them, not behind, so in front. Example could be 7y. So coefficient is this number 7. So basically coefficients are normal number, and you deal the normal numbers like normal numbers, and exponents are the small numbers which are above the letter. Just a quick review that the properties that we are going to learn are actually all on your reference chart. You should have this paper with you, and all the properties are listed over there. They're very easy to memorize as well, but then you actually have the examples in front of them. So the first property that we are working on today is the product of powers. Product means multiply. I'm going to go in detail later. Then quotients, which is division. Power of power, we do it next. And then rational exponents, we do it later. Negative exponents, I think we do it today. So all the properties are given over here. The rules, that's what property means. Like, how do I solve the exponents? So you solve the exponents depending on the format that you get. The first one that we're working on is the product of powers. What is product of power? First, product means multiplying. Powers are the letters with the exponents. So when you see the exponents above the letters, that means it's the power. So this is basically a power. A to the m is a power, a to the n is a power. And then product means when both of them are multiplied. So a to the power m multiplied by a to the power n. And then the rule or the property says, the law, that when the bases are same, a and a is the base. This is the base. So I can label this stuff here. This is base. This is exponent. And together this whole thing is called power. So when bases are same and they are being multiplied, you add the powers. So m plus n, whatever the numbers are here, I'm just gonna add them. How did they come up with that property? Let's review over here. 3x cubed multiply by 4x6. You're not going to see the multiply sign anymore. It's gonna be a dot. So 3x cubed means you have 3 multiply, there's nothing between them, so it has to be a multiplication sign. X cubed means you have x, it's triple. 1, 2, and 3. You have x, triple x. Times, that's the multiplication, that means product. 4 x to the power of 6, you just write the 4 because it's a normal number. And then x to the power of 6 means you have 1, 2, 3, 4, 5, 6x over here. Normal number, you deal normally. So 3 and 4, if you isolate them, it's 3 times 4 because they are being multiplied. So 3 times 4 is 12. You're going to write that 12 down. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. You have 9 x over here. So my final answer should be 12x9. So they came up with the property that, oh, it's 3x and then 6 more. So 3 plus 6 is a 9. So this is your final answer. So that's how they came up with the property. All you have to remember is just when you're multiplying them, you add the same powers. Or you add the powers with the same bases, m plus n. One thing that you have to pay attention to is if you don't see a number, it's always an invisible 1. So invisible 1 is the thing that you have to pay attention to. So x4, I can see the power, the exponent is 4 here, times x, and then I don't see the exponent, so it has to be 1. So always put that 1 so you don't miss. I can totally see it's 4 plus 1 is a 5. They're being multiplied. This is product. So I'm going to add the powers, the exponents. So 4 plus 1 is a 5. Bases can be variables or numbers. Bases is the bottom, but the bases must be same. I can add x and x, y and y. That is what it means. X needs to be added with x. I can't add x or y. It's incorrect. Let's do the first example. When we are doing the examples, we are not going to break them down. If you get confused, then you can break them down. But I'm just going to apply the property because that is what you're supposed to be learning. 5x squared times negative 3x4. So 5 multiplied by 3, that is what you separate out. And then x squared. You can add a middle step though, like that. X squared multiplied by x4. So your final answer is 5 times negative 3 is negative 15. And this one should be x2 plus 4. So my final answer, negative 15, x6. So once you have enough practice, you actually can just do 5 times negative 3, negative 15, and then x squared plus x4, which is x6. So they're not that tough or complex. Again, put the invisible 1 over here so you know how to do it. 5 times 2, I'm just going to multiply these two numbers. And then x4, x1. So 5 times 2 is 10. For the x, it's 4 plus 1. So I'm going to write 4 plus 1. And my final answer is x, 10 to the power of 5. You should be able to do number 2 and number 4 example by yourself. I'm going to do number 5, so you can do number 6. 2a squared b cubed times 5ab4. First thing, pay attention. You have two different bases. You have a and b. So a should go with a. B should go with b. You can't mix and match. 2 times 5 is 10. And then I'm going to have the a put together. 2. And then put the invisible 1. 2 plus 1. Dot. Keep them separate. Use your space. B is 3. And then plus 4. So final answer 10, a cubed, b 7. When you are writing them, so in algebra there is a specific order. The coefficients, they are in front of them, so you first write the coefficient. Coefficient goes here. And when you're writing the variables, they are alphabetized. So you go in the order A, B, C, D, and so on. They're always written in the order. You can't really You're not going to see D before A. That's not how you write in algebra. It's order. The powers matter too, but you're not going to see that right now, maybe later. So this is how you write the answer. The next one is quotient. Quotient means division. So this is the second property that you're learning. When the bases are same and you are dividing them, you basically subtract the power. So in multiplication, you add. In division, you subtract. So this is how I have memorized that when I'm multiplying powers, I add them. And when I'm dividing, I subtract them. So very easy to actually memorize, not too difficult. Again, how did they come up with the law? 6/2, these are normal numbers, so you deal normally. 6/2 simplified as 3 whole. And then you have 4x above, so 1, 2, 3, 4. X squared below, so 1, 2. 1x cancels 1x. 1x cancels 1x. You're left with x2. X squared. So this is the final answer. But 6/2 simplified as 3. And then it was 4 divided by 2 in the power. So you do 4 minus 2 on the exponent, which is 4 minus 2 is also 2. Divide the powers with the same base, coefficient, big numbers. Solve or simplify normally because they are normal numbers. And the exponent, the numbers above, subtract them. All right, let's look at the example. The first one is very easy. I'm gonna do number 2. The first thing in order to make it easier for your eye is kind of separate them out. So I'm gonna use a pencil to show you how. So 3 split. I can actually have 3 splits, and I'm gonna write them separately. So 36/18 goes here. I'm gonna leave some space for x4/x squared and y, x to the power of 4. That's how you read it. Y to the power of 7/y to the power of 4. This is your coefficient, so you solve it normally. 36/18 is 2 whole, so that's what I get over here, 2 whole. This is bases are same and they're dividing, so I subtract the powers. So this should be x4 minus 2. And then for the y, 7 minus 4. And then just simplify this. 2x squared y cubed. This is your answer. You should be able to do number 9 and 10 by yourself correctly. When you don't see a exponent above a letter, it should be 1. So put that tiny one so you don't do wrong subtraction or addition. Solve all these 3. This is the next property which is not given to you on your reference chart, but this is very easy. It's called zero exponent property, which means whatever the number of the letter, whenever they have a exponent of 0, it's equals to 1. No matter what it is, it's always going to be equals to 1. You can check it in the calculator. Solve these 3 from the calculator and see what you get. Let's solve this. x0 is basically 1 because a to the power of 0 is 1. So this is 1, and then y cubed. In math, you don't write invisible 1 or the one like that, so it's this one should be invisible. So this is basically equals to y cubed. X to the power of 0 is equals to 1, and y cubed is equals to y cubed. So that is how I was left with this. Go ahead, solve this one. The next property that you are working on is the negative exponent property. This property is given to you on your reference chart as well. It's over here at the bottom. Now, what does this one means? The negative exponent. That means the exponent is a negative number. So that small tiny number is negative. So what happens is whenever you have a negative exponent, you just flip its position. When I say flip its position, that means from numerator, you make it to denominator. And then if it's already in the denominator, you make it to a numerator. So it's just like you write as a fraction. The mathematicians, they do not appreciate negative exponents. So you're not going to see negative exponents. That's not how they normally write the numbers. You're going to see them positive. So the answer, suppose you end up getting 5 over 3 x negative 3 to the power x to the power of negative 3. This is not how you write the answer. So this x to the power of negative 3 needs to be resolved. So what you do is, what is this position? It's a fraction, and this position is down. That means it's denominator. So all you do is you move this x to the power of negative 3 to the numerator. You move it to the numerator, and it automatically switches its sign. So you take it up, and it will become x to the power of cube. So the way that you remember is cross the line, change the sign. Cross the line, change the sign, S-I-G-N. So cross the line, change the sign. It actually can work both ways. So let me show you another example. If you have 5 to the power of, 5 over 3, and then you have y negative 4. So this is not how you write in algebra. This needs to go down, and I'm just gonna change the sign. So this should be 5 over 3. This numerator goes to the denominator, and it becomes 5 to the power of positive 4. Not negative anymore, because I changed this position. So cross the line, change the sign. So this is one of the very important things that you have to remember. How do we switch the signs? A to the power of negative 8. How do I make it positive? Easy. First of all, it's in the numerator, put 1. And all you do is switch its position, make it go down. So flip the whole thing. It becomes 1 over a to the power of positive 8. That would be the answer. Same thing over here. 5 is the coefficient, so it stays like that. It's over 1. So just, when I say over 1, only this part is 1. So you're gonna flip this and take it down. It should be a to the power of positive 8. So 5, you do nothing because it's a positive exponent. There's no exponent. What there is, it's 1. But you don't write that. So it is 5, and then you just leave it alone above, still in the numerator. You only change this exponent and its position, so it goes down and becomes positive. You should be able to do number 14 example by yourself because it's very easy. I will help you with number 5. So first, if it's difficult for you to see the things, separate them out, cut them apart. So I can actually cut here, here. So 5, I'm just gonna put them separately, and then I'm gonna separate x2 here, and then z3 here. Draw the line, and I'm gonna put y -8 here. So 5 is a positive exponent, it stays there. X is a negative exponent, it needs to go down. Z cube, positive exponent, stays up. Y -8, negative exponent, is down, so this needs to go up. So this needs to come down, and this needs to go up. So your final answer is this, but again, I'm gonna fix these letters. It should be A, B, C, D, X, Y, Z. So 5, y8, z to the power of 3 over x squared. This is your final answer. So all you do is, whenever you have a negative exponent, you just change its position from numerator to denominator or denominator to numerator. Do number 16 example by yourself. The last, not the last property, but one of the properties that you have over here is power of power. Power of power means, this is also in your reference chart, power of power means that you already have an exponent, and then on that exponent you actually have another exponent. So you have two exponents, but they are like that. So a power has another power. So in this case, it's just distribution. You just multiply them together. So this is distribution of powers. So distribute that exponent over whatever the things that you have. So these are easier examples. It's not that tricky. When we have power exponent raised to another power exponent, we will blank the two exponents, multiply. So x squared has a power of cube. So basically what it means is you have x cubed times x cubed times x cubed, and then 2 plus 2 plus 2 is a 6. So your final answer should have been 2 to the power of 3 times 2 is 6. So that's how they came up with this property. So whenever it's written like that, a power has a power, just multiply both of them together, so distribute nicely. X 4 multiplied by 2, and write it like this. This is x to the power of 4 times 2 is 8. So I first wrote 6, mistake, I was going to make a mistake. But then it's 2 times 4, and I saw 4 times 2, it's 8. This is the same way, power of a power, so I'm going to multiply. It should be 8 multiplied by 1/2, or 0.5. You can even write as 0.5, because 1/2 is 0.5. If you can't multiply this part in the in your head, half multiplied by 8, just use a calculator. You can put this part in the calculator. It's 4. So this is your final answer, y to the power of 4. So distribute nicely. If you have, there's no more example over here, but I'm gonna add another example. So if I have x y cubed, and then I have 3 here, and then I'm going to square. So my example should be, I'm going to distribute this on all 3 of them like this. So 3, this is a power, so it should go as square. X, there's 1, so 1 times 2, and then y, this is 3 times 2, and the final answer should be 3 square. This is not 3 times 2 is 6. This is 3 square, which is 9. So use calculator if you can't solve that part. Then x, 1 times 2 is a 2. 3 times 2 is a 6. So this is how you would how you would solve this example. So make sure you copy this one as well. You have a practice at the back that you have to finish.